Okay, hi, hi everyone. I think we are live, so it's showing me live. Let me just quickly check my audio as well. Yep, I am live and I'm audible as well, I believe. So, hi, and today also we'll be solving two problems. Now, I'm trying to give more stress on DP, like in the last few sessions, because like we already had a few sessions on DP, and today also we'll be solving some more DP questions. The reason being that is one of the favorite topics for any interviewer. So whenever you are going to interview for any company, there's a high chance that they will be asking you DP questions in some of the rounds, and definitely Amazon is not an exception here. They also ask DP questions pretty often. So that's why I'm trying to give more stress on DP, so that it's not just that you are solving more problems on DP, but also you're understanding. I'm trying to make you understand as well, like whenever you have some DP problem, let's say you have not seen that problem till now, right? One second. Okay. Yep, I think. Yep. So, hi, Ron. So, yes, you might not have seen the problem till now, but again, like, you will develop that understanding. Like, whenever you see some new DP problem, like, uh, how can you actually approach that problem, right? So that's what my aim is here, like to help you understand that. So with that, let's actually start with today's problem. So again, I've selected two problems today for two problems today. The first is gold mine problem, and after that we have word break problem. Like again, these are very popular interview questions. So first problem, let's read the problem statement. So gold mine problem, it's a easy problem. So given a gold mine M of n cross m dimensions, each field in the mine contains a positive integer, which is the amount of gold in tons. Actually, the miner can start from any row in the first column. From any given cell, the miner can to move to the cell diagonally up to the right, or diagonally downwards towards the right, right? So find out the maximum amount of gold which he can collect. So what it tells is that you have some miner, and he's collecting some gold, definitely. And each field, this mine contains positive integer, which is the amount of, so it's a matrix, and each cell of the matrix contains the value, that is amount of gold available at that position in the mine. And the miner can start from any row in the first and any column, and any row in the first column. So the miner can start from any row in the first column, and from a given cell he can move upwards, right upwards, right, or right downwards. And what is the maximum amount of gold the miner can collect, right? So we have this matrix that's given to us: 133 214064. So the miner can start from here or here, 1 2 or 0. And one second, I think my chroma key is causing some problems, so I'll just remove the chroma key altogether. So just give me a second. Yep. And those, and I'll also, I think now it's better. Okay. So yep. So we have yep, we have 120. This is where the miner can start from, and he can move to the right or upwards or to downwards, right downwards. That is, let's say he starts from one. From one he can go to three or one. This one, right? This three or this one. That is, he can go right or down right? So let's say he goes to three. So 1 plus 3 is 4. So from 3 he can either go to this 3 or this 4. So it's better to go to this 4. So the amount of gold he collects is 1 plus 3 plus 4. That is 7 8. Now let's say he starts from 2. So from 2 he can go to 3, or from 2 he can go to 6. So 2 plus 6 is 8. 8 plus 4 is 10. So from 6 he can go to 4, this 4 or this 4. So both are same. So 10. So he can collect 6 plus 2 8 plus 4 is 12. So he can collect total of 12 units of gold, and this is the maximum, right? So you have to report what is the maximum amount of gold the miner can collect. Now it's pretty simple question. So first thing, like whenever you think of a problem to be DP, is you have to understand whether it's actually a DP problem, like whether the states of the solution are actually forming a directed acyclic graph. So this is a very important, like this is what differentiates between a graph problem and a DP problem. In many problems you will see that the states are actually forming some cycle, like let's say this is a state S1. From S1 you can go to S2, from S2 you can go to some state S3, from S3 you can come back to S1. So it is kind of forming a cycle. So in this case you cannot use dynamic programming, so you probably will have to go with graph based approaches. But whenever your states form a directed acyclic graph, right, whenever your states form a directed acyclic graph, you can straight ahead go with dynamic programming. So in our case, what will be the state? The state, what do we want? We want to calculate the maximum amount of gold, and what is varying? The varying is which cell are we at, or what is the deciding factor that will decide like what is the amount of gold we can collect. So it is the cell that we are at, the cell, or that is basically x comma y. Let's say we are at cell x comma y. So this will decide how much gold we can collect making the moves, right? This will decide. So the current cell that we are at will decide. Now note here, we are allowed movement only in 3 directions, that is on the top right, upright. So it will be x minus, column will remain the same, or column will be plus 1, y plus 1, or to the right. So this will be what? This will be x, row will remain same, column will be increased by 1, or you can go downwards. So it will be x plus 1, y plus 1, right? So these are the 3 moves that you can make. Now if you see, if you look into this, there is no cycle that will be created. Like if you leave a cell, you can never come back to this cell again following some path, because you are always going to the right hand side. So once you leave the cell, you will continue moving on the right hand side. So these states would never form a cycle, right? So they actually are forming a directed acyclic graph. And I believe, like I think you understand this, right? Like if you are at cell x, right, if you are at cell x comma y, you are always going to some x, like it is x or x minus 1 or x plus 1, out of them, one of them. But y plus 1 is always happening. So there is no way, once you go from x comma y to y plus 1, you will come back some way to x comma y again. So there will never be a cycle. So the states are forming a directed acyclic graph. So we can use dynamic programming for our like problem, right? So what is the state again? F x comma y. So let's try to form a dynamic programming solution. F x comma y is maximum number of gold we can collect if we are standing at x comma y. If we are standing at x comma y and we are making the moves, what is the maximum amount of gold that we can collect? So what will be the answer to our problem? The answer to our problem is B, or the thief can start from any one, or the miner can start from any first column cell. So if I comma 0, this is the maximum out of them will be our answer, right? If I comma 0, the maximum out of them will be our answer. That is, what is the maximum amount of gold I can collect if I'm standing at I comma 0, right? If I'm standing at I comma 0, what is the maximum amount of gold I can collect? That is what we want. That is the starting point, and so this is the answer. And what is the base case? The base case will be if any row comma m minus 1, if we have reached the last cell, right? If we have reached the last cell, last column m minus 1, if m I comma m minus 1 will be a of or matrix of, that is m of I comma m minus 1. So this is the base case. If I comma m minus 1, that is we have reached the last column, it will be I comma m minus 1, because after that we'll leave the matrix, right? So this is the last column that we have. So this is fxy. What is fxy again? The maximum number of gold, maximum amount of gold rather, maximum amount of gold we can collect if we are standing at x comma y. Max if I comma 0 is the answer, because we are starting at any point from the first column. If I comma m minus 1 is the base case, that is we are ending at the last column, right? So these are the states and the base cases and the answer. So let's say this is the matrix, right? Let's try to compute fx comma y. So we are directly jumping into the third step, like we are assuming that x comma y is not defined, and we are directly jumping into the third step, that is calculate fx comma y. So let's say this is the matrix. This is just two rows of the matrix, two columns of the matrix. The remaining part is here. Let's say we are at this cell, right? We are at this cell. So what we can do from this cell, we can either go to this cell, or we can go to this cell, or we can go to this cell, right? So if x comma y, we are at cell x comma y, that is f x comma y. What will be f x comma y? Either we can go to f x plus 1 comma y, or we can go to f x plus 1 comma y plus 1, or x comma y plus 1, or we can go to f x minus 1 comma y plus 1, right? We can go into these three cells. What do we want? We want the maximum amount of gold that we can collect if we start at x comma y. So what is f x plus 1 y plus 1? It is the maximum amount of gold if I start at this point, right? So if I start at this point, x plus 1 will be the bottom one. So if I start at this point, let's use a different color. If I start at this point, what is the maximum amount of gold I can collect? Similarly, x y plus 1 will be, if I start at this point, what is the maximum amount of gold I can collect? If I start at this point, what is the maximum amount of gold I can collect? Now we are coming, this will be returned by these three values. So we definitely want the maximum out of them. So we want the maximum out of them. So max of this value. But what is f x comma y? It is the maximum amount of gold I can collect if I start from this point. So we are missing the amount of gold that is present here, because this will return the maximum amount of gold if we start at these points. But this is getting missed. So we'll add that to our answer. So m x comma y plus mx comma y. So this is the recursive solution, right? So this is the recurrence relation for the problem. So let's try to write the code for this, and let me know if you have any doubts, if anyone has any doubts on this. Okay, we have m, so int dp n comma m, right? So let's write the base case first. For int I equals to 0, I less than n, I plus plus, dp I m minus 1 will be equals to matrix of I m minus 1. Now let's solve the problem. So for int I equals to n minus 1, n minus 2, I greater than I equals, for int j equals to m minus 2, j greater than equal to 0, j minus minus. For int I equals to 0, I less than n, I plus plus, right? So dp ij, we'll start with dp ij equals to dp ij plus 1 plus m ij. So if I is greater than 0, in that case dp ij is max of dp ij, or dp, if we go to dp I plus I minus 1 and j plus 1 and plus mij, if this is better. Similarly, if I less than n minus 1, in that case dp ij equals to max of dp ij, whatever we have got till now, or dp I plus 1, j plus 1 plus m ij. I am writing these if statements. I believe it is clear with everyone. You didn't understand the logic. I'll explain again, right? So this is basically I equals to I greater than 0, because like we are ensuring that I minus 1 is not negative, and similarly I less than n minus 1, we are ensuring I plus 1 is not greater than n, right? So let me just re-explain the logic quickly. So what we want is, we first understand the problem, right? So the problem is, like, we are given a matrix, right? We are given a matrix like this. So each has some value, right? Each cell has some value. Let's say it is 2 3 1 4 3 2 0 1 2 4 3 5 1 2 1 0, something like this, right? Each cell has some value. It is told that we can start from any cell from the first column, right? Any cell from the first column. What we can do is, from any cell we can, let's say the cell is x comma y, so we can move to the cell to the right but up, that is x minus 1 y plus 1, or we can move to the cell directly to the right, that is x comma y plus 1, or we can move to the cell just right downwards, right? So x plus 1 y plus 1. So these are the three cells that we can move to, right? We have to move in this way till we reach the last column. What is the maximum amount of gold or value that we can collect by moving like this, right? So this is the question. Now I have already explained why this is a DP solution. Just think about this, that we are always going like this is the state, right? So if x comma y, so x comma y will be the state. That is, what is the state? It will uniquely identify every position that your DP solution will be in. So at any point you will be at any cell, and that cell will determine what will be the answer to your problem. Like which cell you are at, that will determine how much value that you can collect. So x comma y is definitely the state, and if you see that your y is always increasing, like whenever you make a move your y becomes y plus 1, so it is impossible to return back to x comma y again following some path. So definitely it is directed acyclic graph, right? So that's why we can use a dynamic programming solution. Now to understand the DP f x comma y, what is f x comma y? We are defining a function f. X comma y is the cell or the coordinates that we are at right now. So what is f x comma y? Maximum amount of gold. Maximum amount of gold we can collect if we are at x comma y. So the maximum amount of gold that we can collect if we are at x comma y. So for example, if we are at this cell, what is the x comma y value for this cell? It is x will be the row, that is 1 2. So 2 comma or 0 1 1 comma 0 1 2 1 comma 2. So 1 comma 2, this is the cell, right? X comma y. So what is the maximum amount of gold we can collect if we are standing at this cell and we do the moves? That is, we can move to this or this, and like that we continue the moves. What is the maximum amount of gold that we can collect? So that is f x comma y, right? Now what is the answer to our problem? The answer to our problem is, what do we want to find? What do we want to find? We want to find what is the maximum amount of gold that we can collect if we start from any position in the first column. So that is the maximum of f I comma 0. Why f I comma 0? Because f I comma 0 will give you what is the maximum amount of gold you can collect if you start from this cell or this cell or this cell or this cell, and out of them we want the maximum value out, right? We want to collect the maximum amount of gold. So that's why max f I comma 0. What is the base case? The base case will be, where do you end? You end in the last column. So the base case will be f I comma m minus 1. If you are at any cell I comma m minus 1, that is in the last column, the amount of value that you can collect is equals to, or amount of gold you can collect is the same as the cell you are standing at. So m I comma m minus 1, right? So if you are standing at this 2, right? If you are standing at this 1, the amount of value you can collect from here is just 1, because you cannot move anymore, right? So this is the base case. Now we have this state the answer, like how to find the answer in the base case. So what is f x comma y? Maximum amount of gold you can collect. So from x comma y you can move to x minus 1 comma y plus 1, or you can move to x comma y plus 1, or you can move to x plus 1 comma y plus 1. So these are the three moves that you can make from x comma y. So what you're telling is, let's say you take this path x minus 1 comma y plus 1. From there, what is the maximum amount of gold you can collect? That is given by f x minus 1 y plus 1. Similarly, let's say from x comma y you move to x comma y plus 1. What is the maximum amount of gold you can collect if you are standing at x comma y plus 1? It is f x comma y plus 1. Similarly, if x plus 1 y plus 1, it will give what is the maximum amount of gold if you stand at x plus 1 comma y plus 1. Now, what is f x comma y? It is the maximum amount of gold you can collect from x comma y. So either you will take one of these paths, so whichever is the maximum, but to that you will also add what? You will add the current cell that you are standing at, the gold there. So with each of these plus f x comma y will be added. So this is the maximum amount of gold you can collect. So you want the maximum out of them. So you want the maximum out of them. You want the maximum out of these. So this is the recursion and this is the base case. Does this now make sense, Ron? Let me know if it makes sense. So this is the code that we have written, like dpnm. First of all, we have initialized with the base case, that is dp im minus 1 is equals to m im minus 1, and after that we are like we have written the dp loop here, right? And finally, let me know if you have any more doubts. Int max val equals to 0, or yep, for int I equals to 0, I less than n, I plus plus, max val equals to max of max val comma tp of I0, return max val. So this is working fine. Let me know if you have any doubts. Okay, so this is working correctly, right? Let me know if anyone has any doubts. As I'm not telling, I'm assuming that you don't have any doubts, but yeah, like if you do, let me know. So we'll go to the next problem. Next problem again is a DP problem, and it's also a very popular interview question as well. So the question is word break, right? The question is word break. So the question, let's read the statement first. So we are given a string A and a dictionary of n words B. Find out if A can be segmented into a space separated sequence of dictionary words, right? So for the dictionary B, each word can be taken any number of times in any order, right? So you are given a string A and a dictionary of n words B. You have to find out if A can be segmented out into a piece of space separate into a space separated sequence of dictionary words, and for dictionary word, I am from Jadavpur University. So from dictionary B, each word can be taken any number of times, right? So for example, A is I like, and B is I like Samsung, Samsung mobile, ice cream, mango, these things. So what you can do is, you have to tell whether you can break this into a set of strings from B, right? So we can break it like I plus like. So I is also there, like is also there. So we have a valid way of breaking it into this dictionary of characters. So that's why we output 1. Similarly, same thing here, and we have I like Samsung. So we can break it down into I plus like plus Samsung, and we see that I is also here, like is also here, Samsung is also here. So we can write it that this is the answer, right? I like Samsung. Or we can also break it down something like this: I like, then plus Sam plus Sung. That is also a valid way, right? That is also a valid way. I am currently working with Google. So okay, so this is the question. Now we can try to like figure out like what is the solution to this, right? Let's actually try to figure out what is the solution to this. Okay, so we are given the string and the vector of characters. So okay, so let's say I like Samsung, right? Let's take that only. I like Sam Sam. Or let me just write it in caps, otherwise it's not looking good. So I like Sam Sang. Okay. So we have this and we have the dictionary of characters, right? So how will we solve this, right? So again, like we have to tell whether it can be broken down into a set of dictionary characters, right? But again, we cannot do a brute force or a greedy like solution that will greedily take a few characters, will just see if that matches with something, and then maybe like just break it down into that part. We cannot do that because that might actually not work. Like I'll give you an example where greedy like solution. So greedy like solution is like you will see that whether I is there in the list. Yes, it is there, so you will just take I out. After that, L is there, no it is not there, so you will take I to that. So Li is there, Li is not there, so you will take K with that. Lik is there, Lik is not there, so you will take E there. Lik is there, yes it is there, so you will take it out, right? Then S like this, it will start again. So this is definitely one way of thinking about the problem, and this is called a greedy way. But this will not work. Why will it not work? Just I'll give you a small example about why it will not work. Let's say you have something like AAAB, right? AAAB, and you have three strings: AA, and AB, right? So in this case, AAAB, maybe like let's say A is first. So or yeah, like you have B only. Yep, I think this makes more sense. A. So in this case, although here also A, I'm just trying to leave you with some AB. So you don't have A. Just let me think about this a bit. So I want you to be left with let's say I want you to be left with AB, and let's say there are three A's before this. So what you can do is you can map these, and you can map these two, T and yes, and you can map yes, this will work, I think. A. So you have these set of mappings, right? A, and B. Now see here, if you do a greedy like approach, you will first take A. Okay, you will take A. It is not there, so you will take the next A as well. A is there, so you will just separate out A, right? So this part is done. Again, you come back to this. A is not there. A again, A is again A is there. So it will be A is there, so you separate this A out, and finally you have a B, and B is not there, right? So this will not be a valid mapping. What you should have done here instead was group these three A's, right? Group these three A's, A. So this would be a plus AB, and now this is actually present, right? And this is a valid mapping. So definitely a greedy like solution would not work, right? So a greedy like solution would not work, so we have to go with something, we have to go with DP, right? So let's actually now think about the DP states here. Okay, so the DP state will be the current character we are at. So if n is, if it's possible, if it's possible to match the first n characters, if it's possible to map the first n characters to uh, first n characters to if it's possible to break to dictionary words. That is, let's say our n is at this point, is it possible for us to break the first n characters into words, into some dictionary words? In our case it is possible, because we can write something like this: I plus like plus Sam. So this is possible if n is here. Let's say m is not here, n is not here, n is here, n is here. Now is it possible to break it into like set of dictionary words? It is not, because we do not have something like, we do have I plus like plus Sam, but we do not have I plus like plus Sams, or Sam plus S or something like that, right? So it is not possible to be broken. So if n means, is it possible to break the first n characters into some set of dictionary words? Is it possible? So that's what fn stands for, right? Now n is at any point. So what we'll think about it, this is the definition of f, and this is the state n. N is any index that we are at, and we are considering the first n characters. So the task here will be to generate the word, to try to generate a word that ends at n, right? So let's say here we generate, like, n is not here, n is rather here at m. So n is here. We'll try to generate a word that will end at m, right? So we'll try to do this. So am is a word, am is not a word, sam is a word, sam is a word. So we'll try to break it down like this. So fn in our case will be equals to fn minus I, where I to n is a valid dictionary word, is a valid dictionary word, and it will be the summation of, or something like that, or operation. You can have boolean method as well, so it will return true false, and this will be like summation of that part, or of that part, right? So if again, if n will be if summation of if n minus y, where I to n is a valid dictionary word. In fact, not n minus y, it will be fi, summation of fi, because let's say at m you find, at s you find a valid matching, right? So you will go to the previous one, that is here. You will see whether it is possible to match this part, because you have already taken out Sam. You have already taken out Sam and mapped it to something to the dictionary. So we'll try to map this part out. I like, right? So similarly, let's say you have taken up to E or KE, KESAM, and then that's like ILI, like that's left. So that will be the recursion again. Like what we'll do is, we'll for any index that we are at, so fn is the state, so we are considering the first n characters. So we'll see how many words, what are the words that actually ends at this, or what are the valid words in the dictionary that ends at the nth character, and we'll try to figure them out, and we'll records, because this is a word that we are separating out, so remaining part has to be separated out into dictionary words. So if it will be summation of those fi's, right, or of those fi's. So that's basically the logic for this. Let's try to write the code. Okay, so we have string s. So what we can do is, we can maintain a hash map of these vector string. So unordered map string boolean mapping, or dictionary, let's call it a dictionary dict. So for string s belongs to b, let's pass references b, and we'll add it to the dictionary. So dictionary of s equals to true. So in dp int n equals to a dot size, in dp n plus 1, and will fill it with 0. So fill dp tp plus n plus 1 and 0. So for int I equals to 1, I less than equal to n, I plus plus, So this is the ending point, right? This is the ending point. So for int j equals to 0, uh, so for int j equals to 0, j less than equal to I, sorry, j equals to 1, j less than equal to I, j plus plus, will see, check if, check if okay, check if what, check if j to I is a valid substring, is a valid string in dictionary. If j to I is a valid string in dictionary, so we'll maintain this string temporary as well. That will maintain the running string. So temp plus equals to okay, j to I is a valid string or not. So this will, okay, we can use the substr method, I believe, right? So, or we can use the substr method. I'm just thinking about, is there a better way to generate the we can definitely go for hashing. So what we can do is we can definitely go for something like hashing and get it done, but I'm just thinking, is there a better way to actually compare, like if it is there in the um, there or not. So I think the best way around here, I believe, would be hashing only. I don't see a better way, but again, like, I'm not going to talk about hashing in this, right? So let's actually do it in a bit unoptimal way. So string substring equals to uh, b a dot substr from j to I, j minus 1 to I, yep, j minus 1 to I, and we'll check if and this is the order of n, right? So it actually is becoming a order of n cube. So we can reduce this n cube by actually using our hashing. Like, we can just compare, we are just comparing if this string is present in the dictionary or not. So we can easily do that by hashing as well, right? So we can hash this substring, and then we can check in order of one time. So this entire thing would not be needed at all. So we'll check if dictionary of substring is true. In that case, dp of I is equals to plus equals to dp of j minus 1, right? So dp of I plus equals to dp of j minus 1, and dp of 0 is 1. Let's write dp of 0 equals to 1. So that should be there. And finally, return should be dp of n is greater than 0 or not. If it is greater than 0, in that case it will return 1, else so dp of n is greater than 0, in that case 1, otherwise will return 0. So that should be the return statement. Sorry, so let's try to run this. Okay, this is working, so let's try to submit. Probably it might time limit. It's giving wrong answer. That's interesting. So IAJXLO HQ, and we have HHQ. Why is it a wrong answer for me? J equals to 1, j less than equal to I, j plus plus, yes. And let me check substr in C++. So substr in C++, it is including or excluding. Let me just quickly check that. So substring 3, okay, it will take from position 3 2 characters. uh, got it. It will second is the number of characters that we want to take. So from position j minus 1, we want to take j minus I minus j characters, right? I minus j plus 1 characters actually. So from position j minus 1, we want to take I minus j plus 1 characters, because j to I both are inclusive. So let's actually test against this custom test case. So it will be 3 IAJ XLO HQ and HHQ HQ. Let's try to run this. Okay, now it is working, so let's try to submit. Yep. So this is giving a time limit exceeded. And why is it giving a time limit exceeded? It makes sense because it is going for a n cube time complexity. Um, what we can do here, so we are actually increasing. What if we so we can just so what I'm trying to do here is I'm trying to make the strings incremental, right, so just so that we can add to the strings, so it ends at I. Instead of that, we can just mark it as the starting point of I, like how many strings are there that starts at I. So we just have to reverse this, right? So what our logic was, in fact, we do not even need hashing here, right? So the logic was, how many strings are ending at this point, and we were figuring that out. Rather than that, we are figuring out how many strings start at this point, and we take like enter there in the dictionary, right? And we find how many the instead of the first n characters, we are considering the characters from n to the n, right? So that's how we can also do. So n plus 1, and fill dp, and dp of n minus 1 is equals to, or n dp of n is 1. So dp of n is 1. So for int I equals to n minus 1, I greater than equal to 0, sorry, greater than equal to 1, dp of n is 1. So n minus 1, dp of n is 1. Dp of n means we have reached the end, so dp of n is 1. Yes. So I should it be dp of n is 1? We have reached the end, yes. So dp of n is 1 because there's nothing to match, and n minus 1. Okay, so I greater than equal to 0, I minus minus. So this means that, okay, so this means that if how many strings, so we have to find strings starting at I and matching with dictionary, right? So for int j equals to I, j equals j less than n, j plus plus, yes. And we'll also maintain a string temp. So now it's incremental, right? So temp plus equals to a of j, temp plus equals to a of j. If string of temp, if it's there, then this will be the condition. Now we'll check for dp0 here, dp0, like whether we can start at 0 or not. So let's compile and run this and see if this is working. It is not. So dp dp n plus 1. So basically what we are doing, let's actually rewrite the conditions again. Let's rewrite the conditions again because we are reversing the loops, right? So it might be something with the conditions. So yep. So what are we doing here is, so given n or given I, if I will be what, how many strings can we divide I to n minus 1 into paths belonging to dictionary? Can we divide I to n minus 1 into paths belonging to dictionary? So if I equals to what, it will be equals to fj, summation of fj, where I to j minus 1, or it will be summation of fj plus 1, where I to j minus 1 is in dictionary. So is in dictionary, right? So I to j minus 1, I think the condition here have reversed. So let me just check. Yes, it should be j plus 1. right? It should be j plus 1. So we are taking I to j, so it should be j plus 1. So let's run this now. Now it is coming fine. So let's try to run this, compile and run. So these are like small optimizations that you can always make. Yes, this is also working. So again, like although hashing was a better solution here, but again, like this was a small optimization that I could have made because I was unnecessarily generating the strings every time. So instead of that, again, like it's coming time limit exceeded, although I'm just doing temp plus equals to a of j, dictionary of temp. Okay, I'm comparing here. So we have to go with hashing because here also, like when we compare, we have generated, yes, but when we compare in dictionary, in that time we have to have like we have to see whether uh, we have to have some form of hashing. In fact, yeah, like we have to do some hashing here, so we can maintain some hash function. Actually we can do that as well. So what we can do, this comparison, this is like being converted to hash, so maybe that's why it's taking time. Dictionary of s dp for int I equals to n minus 1 I greater than equal to 0, and this is only for like possible ending points which are valid mapping. So in fact, s, yep, n is 12. What is n? Okay, n is 12. So n is maximum, n possible is 12, like 12 dictionary words. So can we do it in terms of s into n? That is, we'll see if there's, although that wouldn't make a lot of sense. Okay, so we have to go with hashing here. So what we have to do is we have to convert this string into like we, instead of generating the string, we have to do a hash. We have to find uh, like we have to figure out some hash function, generate it dynamically, and then compare like if it is equals to the hash of the strings available here, right? So that's something that we have to do, and I don't think we can do without that. So that's something that we have to do here. Yep. So again, like it will become bigger like if I try to explain the hashing, but again, like this is the solution definitely, as most of the cases are passing. So what we can do here is like again the solution will be like just create a method that will like find hash value. So that will find a hash value for the string. So pass the string as an like, right, so pass the string as a parameter here is string a, and pass the starting point and the ending point whose hash value you want to find. So something like that you can do. Or what you can do is you can find like as you are adding, like for that will be valid for these strings, but for this string you can actually dynamically, like if you generate every time, that doesn't make sense. So what you can do here, instead of temp plus equals to a of j, you do is temp plus equals to hash of a of j, right? Hash of a of j or something like that, hash of a of j. So you can do something like that, and that will like compare between integers. So that's something that you can do. Other than that, I think int, instead of int we can maintain a boolean. We can try small optimizations, not sure if it will work, but yeah, let's try this as well. So if we maintain a boolean instead of string, so let's maintain this to be true, and initially it's false, and j equals to dpi or equals to dpj plus 1, and return dp0. If it's true, then 1 else 0. So let's try to submit this. I don't think this should work again, but uh, we have just saved some space. Yep, it should not work. So yeah, I think hashing should be the way. So just do hashing here, and that should solve the problem. Anyways, I hope that the questions like how are we solving the problem, it's pretty clear to you, like how we are optimizing as well, and small optimizations that we can make. So yep, thank you guys for joining in, and I'll be seeing you in the next class. And let me know if you have any doubts. Let me know if you have any doubts with the problem statement. All right. Thank you for joining, and I'll be seeing you on the next.